Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is a hot topic out there. Hopefully, when we go through this, and by the time we're done, we'll have cleared up some confusion that I know is out there as well. So we're talking all things module setup, so coding, programming, flashing, and others, such as resets and relearns too. So if you've been around the industry long enough, at least a few years, what have you, talking to people out there, you may have noticed people say, "Oh yeah, programming, coding, flashing," seem to use those terms pretty interchangeably out there, right? And they are three different things. We'll discuss that, and then also reset and relearn can be a little confusing in there as well. So the goal of this session is to try and help you clear up the confusion through each of these, and we'll give you examples of each, and then we'll go live on the tool and show a couple examples as well. So first off is resets. So with resets, what resets are designed to do is they're used to reset a parameter back to factory specs. For example, oxygen sensor heater and transmission shift adaptives, for just two examples. On the oxygen sensor heater, we're going to walk through that procedure here in a second, but this is on specifically the one we're going to talk about is 06 and newer GMs. On those vehicles, what happens is as the heater circuit on the oxygen sensor wears out, it heats up, cools off, heats up, cools off, heats up, cools off, heats up, cools off. Every time that cycles, a little bit more resistance comes into the circuit, and it gets more and more resistance. Over time, to compensate for that, the ECM learns that it needs to increase the amount of amperage flowing through that circuit. It'll keep increasing it till eventually, just one of these days, the sensor decides to fail. Either the heater circuit itself fails or the sensor itself fails, whatever happens. And you're going to replace that sensor, right? And then when you do replace the sensor, use a brand spanking new sensor, has much lower resistance than the one you just replaced in the heater circuit. And when you put it in there, if you haven't reset the computer, it is going to be sending that excessive amperage down the line, that heater circuit. And what happens next? Well, that heater circuit blows out pretty quick, usually in the first few hundred miles. And we've had people tell us, "Oh yeah, I replaced 3, 4, 5 of them before I figured out what I needed to do." And all you need to do is a simple reset of the computer. So all a reset is, once again, so whatever the computers happen to adapt its adaptives to, it's just resetting them back to where they started, right? And then everything relearns where it needs to be. So in this example on the oxygen sensor, have the 2016 old standby Tahoe there. For most of these, many of these, by and large, service resets, relearns, a lot of the programming and coding functions as well, to a point, are going to be under this service resets and relearns section of the tool here. And that's on the intelligent diagnostic tools. On tools that don't have intelligent diagnostics, all of these resets are still available. You'll just have to go straight into whatever module you need to perform the reset in. So this kind of makes it nice and easy to get in there. So we'll go to service resets. And then we see they have the resets, relearns, etc., sorted by the module, right? So engine, anti-theft, body controls, etc. So in this case, we have replace or relearn an oxygen sensor, because it's really sorted by job, right? So I replace the oxygen sensor, or if I replace the evap canister, or if I replace the evap vent solenoid, etc. These are things that we would need to do. So replace or relearn the oxygen sensor. And go in there, and then it gives us repair information, top repairs graph, any TSBs that apply, and then that actual heater learn is going to show up down here underneath our resets. So we'll click on that, and it says on the next screen, just select reset. So we'll hit continue, and then there's that reset button on the top left-hand corner of the screen. It tells you what the data is reading currently, the current data, and we'll hit reset, and it resets it. That's it. Most resets are like that. It's just I'm going to clear it. It's going to reset it back to where it was, and then it'll learn itself back to where it needs to be. All right, and that brings us to relearns. Relearns is similar to a reset, and I think that's probably why we get some confusion in there. But what relearns are used for is to teach the ECM the parameters of a replacement part. For example, throttle body relearn, valve body relearn, tire pressure monitoring system. So if we think about a throttle body, I'm going to replace this throttle body, and it's never, ever going to be exactly the same as the one you replaced, right? It might look the same. And for if you even look at the where the throttle plate is, etc., it's going to look the same, but it's not going to be calibrated the same way. So what a relearn will do, especially in like the throttle body instance, you'll plug it in, you'll hook it up, you tell it to relearn, it goes through its entire sweep range, and then it figures out where 0% is and 100% is. After doing that multiple times, it figures it out, and then it's able to adjust due to the range of that particular throttle body, because every manufacturing tolerances and everything's a little bit, even if it's just millimeters difference, that's all it takes, right, to have a high idle problem or something like that. So that's why you need a relearn throttle body. TPMS, same deal. If I replace a TPMS sensor on the tire, well, the computer needs to know what the code that is being transmitted by that tire pressure monitor sensor is, right? So it has to know to look for it, right? So it'll have a long code, and maybe you have to type it in. Maybe you just simply hit a little electromagnet next to the tire, and that'll relearn it. Oftentimes, you have to put the computer into a learning mode to do that as well. So that is a relearn. So in this case, we'll talk about a relearn on a 2012 Nissan Murano and throttle body relearns. I know throttle body relearns and Nissans go hand in hand. They're fairly common. So we go to service resets again, and we have an idle learn procedure, right? So that's what needs to be done after the throttle body is replaced. So we go to idle learn procedure. Replace and relearn throttle body, we also could have gone there too. It brings us to the same place. So we go in here, idle air volume learn. It's going to learn the idle air volume of that after it's, once I said it goes back and forth. So idle air volume learning is a function to learn the idle air volume that keeps the engine idle speed within a specific range. It must be performed under any of the following conditions. Actual vehicle applications may differ, but each time the IACV and AAC valve, the throttle body, or the ECM is replaced. So if you replace the throttle body on this, you need to do this test, or the idle air control valve, or the ECM. So idle speed or ignition timing is out of specifications would also be a reason we'd have to do this as well. So we continue. And then it says, perform the accelerator pedal release position learning first. So we'll make sure the accelerator pedal is fully released, so don't touch the accelerator. Turn the ignition switch on and wait at least 2 seconds. Turn it off and wait at least 10 seconds. On for 2 seconds, off for 10 seconds. Hit continue. And then throttle valve close position learning. Make sure the accelerator pedal, once again, fully released. Turn the ignition switch on for 2 seconds. Turn it off for 10 seconds. Then confirm the operating sound of the throttle valve during that 10 seconds. So you should be able to hear outside in the engine, you can hear it adjusting itself back and forth. Continue. And then performing the idle air volume learn, make sure all the following conditions are satisfied. Now, this is one reason we have this on the screen, because if any of these parameters goes out of spec, it will be canceled. So learning will be canceled if any of the following conditions are missed for even a moment. Even a moment. I've had people tell me, oh man, this is a really hard one to do. Or, hey, the scan tool doesn't do it. Yeah, the scan tool does do it. It's just that maybe one of these parameters changed. So battery voltage has to be more than 12.9 volts at idle. So I guess our alternator needs to work. Engine coolant temperature, 158 to 212 degrees Fahrenheit. Gear selector in park or neutral, so it has to be warmed up, has to be in park. And idling. All electrical loads off. That includes AC, headlamps, rear window screen defoggers, cooling fans, anything, radio. All electrical loads need to be off. For vehicles equipped with daytime running lights, set the parking brake so the lights don't come on. Right? That's another thing. Steering wheel, make sure it's straight ahead and centered. Vehicle speed stopped at 0 miles an hour, and the transmission warmed up too. The transmission has to be at operating temperature, so that means we need to drive the vehicle for 10 minutes. Key on engine running, and idle not excessively high. Now, they don't tell us what excessively high is, but I would just say, maybe probably less than 1,500, I would imagine. Any non-idle related codes cleared or repaired. So we need to have all of these parameters set on the vehicle, and you need to know that they're set up before you continue this test, or it's going to fail. All right, so let's just assume that this happens. So we'll hit continue. And then it says if all conditions are met, key on engine running, select continue, and the test will start it. It'll automatically function through the test that it needs to do, and then it'll tell you when the test is complete. So we hit continue, and then the test will go in progress, and then that will be that. All right, it'll give us the test completed screen at the end. Couldn't do that with my simulator, but you would see a test completed at the end, or you would see a test failed if the test failed. Either way, and then you would just restart the test. So that is Relearn. Now we get to coding. So coding is a type of a relearn, I guess you could say. So coding is used to teach, once again, just like the relearn, it's used to teach the ECM parameters by using a code number of some sort. Now, either you manually type that code number in, or the code number resides elsewhere in the vehicle and it needs to get programmed in. For example, fuel injector coding, which if you're here at the beginning, we saw that on a Ford. I'm going to show you another example on a Sprinter in a minute. And then proxy alignment. Proxy alignment is big on Fiat Chrysler vehicles, mainly the ones designed and built by Fiat. But proxy alignment, it's kind of a cool little test here, a little coding for us. So if we look in the shop key information here, so the body control module stores and compares vehicle configuration data with the instrument cluster, as well as with other electronic control units in the vehicle. This process is referred to as programming of configuration of systems integrated, or the acronym proxy with a C, and then also known as proxy with an X. I don't know why they decided to change it, but also known as proxy there. So if a configuration mismatch is detected, so if I've installed a new computer for some reason, one of the computers, if it's mismatched, the BCM sets a DTC. A configuration mismatch DTC will require the performance of a restore BCM proxy configuration routine or a proxy configuration alignment routine using the scan tool. So that's what we're going to walk through now. So that's called a proxy alignment. So we go into the vehicle itself on the main menu. It's actually not listed as a service reset or relearn. It's actually listed on its own under body controls. Here we have a proxy alignment setup. So we're 2313 Fiat 500. So we go into proxy alignment. And then there's a perform proxy alignment procedure or stop communication to exit. So we'll perform the procedure. And it says this procedure is used to display the proxy configuration status of the entire vehicle and copy the proxy configuration data into any required ECUs. Continue to display the current vehicle status. So we hit continue, and then it shows us whether or not it is configured. So in this case, it says the instrument panel cluster and the radio are not known as to whether they're configured, but the tire pressure monitor and the CTM module are all configured. So it's going to be able to copy it from another stored location, the code from the other stored location, copy it across and put it in these modules. So I continue. Complete the process, turn the ignition off now and wait for the displayed countdown timer to finish. It will go through the process. It doesn't take very long. And then the proxy alignment procedure will be complete. Easy enough. So that needs to be done anytime a module needs to be replaced on that vehicle. So it looks like 4 or 5 different modules. Now we get to the one that seems to get a little bit confusing between programming and flashing. And part of that's some of the company's faults as well, because they talk about programming computers, right? Really, a programming is going to be a different procedure than a flashing, right? And let's talk about that. So programming is used to change the ECM parameters. So I'm going to go in and program the ECM
to do something that it isn't doing right now. Example, all doors unlock with a key fob. So I go in the BCM, I can set up in the program that I want all the doors to unlock or I want just the driver's door to unlock. I can also change whether or not the alarm chirps back at me when I arm it, things of that nature. So here's an example on Subaru. I just added this function earlier in the last year. It is for the body integration unit, which is their word for body control module. And we can see all the different things. I'm going to give you a little bit better view of this a little later when we go into the live portion. But if we see auto lock time is set for a default of 0 seconds. All we have to do is hit edit. We can go in here and it gives us the selections that we can set. So for auto locking, we can set it up to 10 seconds, up to a minute. So we go, let's say 20 seconds, and then we go to program, and then it programs it in, right? So hitting the program button to program the computer, that kind of makes sense, right? And then it gives us the indication that it has been customized and changed. Right? Many different vehicles have these types of functions. I just know we just added it on Subaru a little while ago. I've seen it on Volkswagens, Audis, BMWs. Many different vehicles out there have it. So we just that's just one other thing that we can do. So that is programming. Now we get to the big one, the flashing. Right? There are many things that we need to be aware of when it comes to flashing. We're going to give you a high level here because this isn't intended to be a full flashing course because every manufacturer is different. I think we'll see that in a second. So what flashing is, if we think about why we call it flashing, if we think about the chips inside the computer, they run firmware. In order to put firmware on the chip, you need to use a process called flashing that chip. If you've been around a long time and you can remember changing proms out of cars, out of computers. So instead of changing the prom to change the program, we're just flashing a new program to that prom, if you want to think of it that way. So it's used to write software to the ECM. Examples of when you would do that is replacing a blank module for sure. So I get a brand new module. I know, for example, Chrysler's pretty good at that, just sending you a very minimally configured, if at all configured modules, essentially a blank computer. You plug it into the vehicle, then you have to put the proper file for the proper vehicle on there. And most of the time, just about all the time when we're flashing, it has to be the proper file, don't get me wrong, but it's essentially I'm taking a blank module and I'm putting all the software on it to run it. Or a software calibration change. That happens all the time. So a TSB or a campaign from the manufacturer, you have to rewrite the software on the computer to change some sort of calibration that caused some sort of an issue. I know back at Subaru, we did tons and tons of these on bulletins. A lot of them were for cat codes. So they were burning out a lot of cats for a time there, mid-2000s or so. And the reason why they were burning out a lot of cats is because the calibration in the computer was set for the mixture to be too lean. So to get our fuel economy, we need to lean out the fuel mixture a little bit, right? So it was set a little too lean, and lean will light off that cat pretty good, and it was burning out the cats. Right? So what they did was they came out with a bulletin for the manufacturer, a campaign. Customers would bring their cars in, we'd flash them, and they'd leave. And that would solve the problem. Now, also, I guess as a side effect of that, we had some customers come back not that long after, maybe a week or two later, and they say, hey, my fuel economy is terrible now. What'd you do to my car? Right? And what it was is they changed the calibration in the software by flashing it, and it increased the amount of fuel used. So they richened the mixture. So yeah, you're using a lot more fuel. And then over time, they came out with a couple other ones to adjust it back a little more. Because I think they probably had a few complaints from customers, but you know that's just kind of a personal story that happened. But yeah, replacement of a blank module, software calibration changes. Now, when it comes to flashing or reflashing, whatever you want to call it, flashing or reflashing, I guess we can use those interchangeably. You need to use a laptop and some sort of a flashing device. For example, a J2534 box, which is pretty well an industry standard there. Oftentimes you will want multiple laptops because they don't always play nice with each other. The different manufacturer software sometimes can corrupt each other. and different manufacturers have different requirements as far as how their software will work. Here's an example here from Ford, right? So Ford will have issues if, and let's see, if we have any issues, these are the following items that will cause an issue. They're listed from the most likely to the least likely cause. So if I'm trying to use Ford software and I am having a problem, they say the most likely cause of the problem is Windows Firewall and Windows Defender, antivirus software. Second most common, third-party antivirus software. So you can't have antivirus software on your computer. Internet Explorer configuration. By the way, you can only use Internet Explorer. Cannot use Chrome, cannot use Safari, cannot use Microsoft Edge. Has to be a Windows-based computer. Has to have .NET framework on there. Needs to be up to date. Computer hardware operating system. If they don't have the certain hardware in there, it won't work. We need to make sure we configure Internet Explorer 11 using the following 15 steps. So there's 15 things you need to do using Internet Explorer 11 only in order to flash a Ford. Right, it's got to be exactly correct. We need to go through and make sure we have trusted sites in there. And I'm not going to go through all this, but there is a laundry list of settings that need to be done, and that's just for Ford. And if I want to do GM on the same computer with the same configuration, it's going to be different because GM asks for a different version of Java. And then Chrysler asks for a certain configuration, and Honda's a certain configuration. Everybody has their little bitty differences. Some will allow you to use Chrome. Some won't let you use Chrome. Some will let you use Windows 10. Most everybody's on Windows 10 now. But for a while there, a lot of them wouldn't allow Windows 10. It'd be Windows 8, Windows 7. Right? So a lot of them are dropping support for that, thank goodness, so we can all get on Windows 10. But still, there's many differences out there, and you need to be aware of that. There's a couple industry sites out there that have this information there, and you can go straight to the manufacturer to find it out too. That's how I found all this out, so how they do it. But also note, each manufacturer is going to cost you something different. Right? Most of them offer day passes, which is nice. So if I only have one card to flash, if it's an Acura, it's $30, and then each flash is included, so that's nice. But if it's Hyundai, it's $60 for a week, $75 per flash. All right. It also allows you dealer level on 2018 and newer vehicles, Diagnostics, but differences. BMW $30 for a day, Ford $50 for 2 days. All right, so it's different. GM is now down to VIN, so it's $40 per VIN for a 24-month period. So 2 years where you can flash the same VIN. Right, so it's all these differences that you need to be aware of there. Here's just another list of the other half of the vehicles. Right, Mitsubishi's $20 for a day. Volkswagen's $130 per brand per week. Volvo's $63.60 for 3 days, et cetera, et cetera, et cetera. Or if you're trying to flash one of these vehicles, like a BMW, Chrysler, Ford, GM, Honda, Acura, Hyundai, Kia, Mercedes-Benz, Nissan, or the Toyota Lexus Scion family, we also have this pass-through assistant that's available. And the guy on the other end of the phone worries about all the problems and all the configurations. So this hooks up to the vehicle through the OBD2 port, plugs into the wall. It's actually a battery maintainer built in as well. So you hook up jumper cables to this, so you have to maintain the battery. That's another thing I didn't mention earlier. So along with the laptop and the J2534 device, you also want a good battery maintainer, because if the battery voltage spikes or drops, you can lose a module. So the pass-through assistant definitely takes a lot of that fear factor out, I guess. Maybe not the fear factor, but maybe the complexity out. Right, so it's on most of the major manufacturers, right? So GM, Ford, Chrysler, etc. So it's available out there, and it makes life a lot easier for the tech. You basically set it up. You call, make your appointment. You set it up before the appointment time. They call you when it's your appointment time. They dial into the vehicle. They perform the flash, and they worry about it. Right? All you really have to do is plug it into the wall, plug in the jumper cables, plug it in the OBD2 port, turn on the computer. So it's got a built-in tablet computer inside. All right, so that is the easiest way when it comes to flashing for sure. So hopefully so far, we've cleared up some of the confusion as to what is what. And let's walk through a couple live scenarios now with this. So first one I want to do is I want to talk just a little bit more about that GM oxygen sensor reset. All right, so I'm going to pull up our demo truck here. Load that, and we'll talk about that real quick. Okay, so service resets and relearns, just like before. Go in there, and we'll do the replace relearn oxygen sensor. And in this case, instead of going right to my functional reset, I want to learn a little bit about this first. So I'm going to go to my repair information. Now, if you have Shopkey or Mitchell, this will link you to your Shopkey or Mitchell account, logs you in, logs the vehicle in, and brings in information based on what we were repairing. So I'm going to pull an LTZ, gas engine, four-wheel drive. Okay, so it pulls up oxygen sensor. So if I'm going to replace my oxygen sensor, I'm going to go in here. And then the best place to look, if I want to find out what resets, relearns, what do I need to do after the repair, we want to go to after repair. So I go in after repair info, and the only thing under after repair is the only thing we need. But when replacing the oxygen sensor, perform the following: a code clear with a scan tool, regardless of whether or not a DTC was set, and the oxygen sensor heater resistance learn reset with a scan tool where available. Perform the above in order to reset the oxygen sensor resistance learn value and avoid possible oxygen sensor failure. So they want you to clear the memory first and then do this reset. So I can pop back over to my scanner. Let's say we already cleared the memory. We'll go to oxygen sensor heater learn. Next screen's flush reset, hit continue. There's my data. There's my reset button. Click reset, done. And it takes that long in real time. All it does is just sets it back to 0. And then it works its way back up to where it needs to go. Or probably not 0, but it sets it back to factory settings, whatever they happen to be. All right, so that's a reset, real easy, right? Let's talk coding. So let me pull up my, let's see, what do I got here? Here's my Sprinter right here. I got a 2014 Sprinter loaded. Okay, so there it is. Now on this particular vehicle, we don't have service resets and relearns available, but that's okay. We can go into the engine, and I have to choose my vehicle. There we go. This is a diesel, it's 3-liter diesel. If I go into functional tests there, so it's going to be under functional tests, and then there are special functions. First things first on the special functions, other than maybe throttle valve actuator, speed limiter, compression test, load time output stage, cylinder cutout test, DPF regens, all of these things on a Sprinter. But I need to, if I need to replace the injector, I need to program the injector. For continuing, make sure key is on, engine is off. When replacing an injector, it's essential to save the QR code of the new injector in the injection control unit, on the engine control unit, sorry. This process ensures that the necessary correction parameters for the injector will be recorded in the engine control unit. These correction parameters enable the engine control unit to meter the injection quantity precisely. This is very common on diesels. It's very common on, I know BMW, we have it for that as well. A couple other manufacturers out there require this function in there. So when I replace an injector, every injector is going to be, no matter what, they're going to be built a little bit different. And that little bit of difference and a little bit of flow rate, the computer needs to know what that setting is. So that's why we have to have the code for it. So usually it's either on a certificate or inside the box or printed on the box itself, something of that nature. Hit continue. QR code of the injector consists of 7 characters located on the top of the relevant injector. So in this case, it's on the injector itself. Hit continue. And then here are my programmed injectors. All right, so that has our 6-digit. Let's say I replace number 1. So we'll go in there, and all we have to do is type it in. That's not 6. 1, 2, 3, 4, 5, 6. There we go. So let's say that's what I need. There's my new ID number. Double check it. Hit OK. Oh, well. Oh, it's a 7-digit. There we go. 7-digit. There we go. Okay, well, fine. It's not working in the simulator, but that's okay. So there's where it would be. All right, so that's how you would program it in without the simulator. All right, and then all I have to do is hit OK, exits the test. So that is coding. All right, so we're all done. All right, so that's coding. Next, let's go to, what's my other one? Subaru Forester. So on the Subaru Forester, we're going to do some programming. So once again, Subarus are really weird when it comes to their functional tests. So we don't have a list there, but we do have our body integrated unit. And we'll go in here and program some settings. So we can go into functional tests once again. And then we have unit customizing. So when using this function, all available items will display with the current settings. You may change as many times as needed. To change a menu item, highlight the item, select one of the choices provided in the submenu. Exit to the main configuration or customization menu. Okay, so we'll do that. Some options are not available on all vehicles. If they don't have the thing, you probably can't program the thing. Like power rear gate. I know my car doesn't have that. So let's see. So auto lock time, light sensitivity adjustment, remote trunk open, lane change signal setting, rear wiper automatic setting, TPMS setting. Does it have TPMS or not? Driver door unlock setting. So do I want to unlock all of them or just select just the one door? All right, so we can do that. Hit program. It goes one touch turn signal, auto wipers in the rear. Let's see, steering wheel, right hand or left hand drive. Let's see, where's a couple important ones here. What we used to have to do at the dealership, high beams. Here's another example. High beams, low beams. Are they halogen? Are they HIDs? Or are they LEDs? So if you change it to LED lights, you can change it and it changes the specifications. Let's see, defogger, normal or continuous. So normal will run for like 10, 15 minutes and then shut off. Continuous, it's continuous till I turn it off. Actually want to go in there and do that on my own car. Security alarm setup. Does it have an alarm? So when we would install a dealer installed alarm, you would have to go in a body control module and you would have to turn on the alarm to start. And then if it had an impact sensor. Now, if you've been to any of my classes before, like the network class, I talked about there is a connector underneath the seat. And that had a CAN connector on it, right? So that is where we would put the impact sensor. The impact sensor for the glass is under the seat. And when you plug it in, you have to first tell it whether or not it has it. So it has it, right? So support that. And then whether or not the impact sensor is on. All right, so hit support there. And then that's all we would do. We would program it, and then the vehicle will be ready with their alarm and the impact sensor. So this has real applications out there in the real world other than just convenience for the driver, right? So it's multiple different settings in there. Most of them you won't use, but that capability is there, and that is a programming capability. I'll hit program to finish up. It'll write the values where it needs to be. Do I need to try again? No, I'm good. And then do I want to see the summary? Yeah, sure. Let's show the summary. So here's what changed and what didn't change. So with successful change there, didn't change a lot of the other stuff, right? Hit OK. Oops, hit the wrong one. There we go. So there we go. That is programming. So that is resets, relearns, coding, programming, and flashing. I can't flash with my scan tool. Nobody can flash with their scan tool.
And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.